Shared work problems. In this video, we'll set up and solve problems where machines or humans are working together at different rates. This is a shared work problem. A swimming pool has two drainage pipes. When the pool is full, the first pipe alone can empty it in 150 minutes. And the second pipe alone can empty it in 100 minutes. Both pipes are draining together. That's the shared work. How long does it take them to empty the pool? Now, a lot of people start thinking about the average of 150 and 100, but that's not what's happening here. The result should always be less than the lowest amount of time, because the other pipe is helping it do it faster. Now you know that rate times time equals distance or job done or whatever. And one pipe is working at the rate of 1/100th of a pool per minute. And the other pipe is working at the rate of 1/150th pool per minute. So those are the two rates, and they're going to be working together, and they're multiplied by the time, and together they're going to drain one whole pool. The way we usually write this is by distributing the t, that the time together over 100 plus the time together over 150 is equal to the whole job done. I'm going to clear fractions by multiplying by the least common denominator, which is 300. So I multiply each side by 300, and I get 3t, that's 300 canceling with the 100, plus 300 canceling with the 150 gives me a 2t, and 300 times 1 is 300. So 5t equals 300, and t is equal to 60. That means together it takes 60 minutes to empty the pool, because t stood for time in minutes. Notice that the result is less than both the two times. An older machine takes 360 minutes to produce 7,200 bottles, but the newer machine takes only 180 minutes to make the same number. How long will it take the two machines working together to produce 7,200 bottles? Well, the thing is, I don't really need the number 7,200. It's one job, so we're going to write one job equals 7,200 bottles, and that's all we need that number for. The older machine finishes 1/360th of a job per minute, and the newer machine finishes 1/180th of a job per minute, and they're both multiplied by the time it takes to finish one whole job. So t over 360 plus t over 180 equals 1. I want to clear fractions, and the lowest common denominator is 360, so I'm going to multiply both sides by 360. That will give me t plus, and 360 divided by 180 is 2. So t plus 2t equals 360. 3t equals 360. So when I divide by 3, I find t equals 120. That means both machines working together can finish that job in 120 minutes. And notice that it's less than both 360 and 180. Working together, Paula and Daniel can pick 40 bushels of apples in 4.95 hours. Had he done it alone, it would have taken Daniel 9 hours. Find how long it would take Paula to do it alone. So in this problem, we have the time together already, 4.95 hours. We're looking for one person's alone time instead. Here, one job is 40 bushels of apples. Now what we did before was rate 1 plus rate 2 times the time together equaled one whole job. Now I know that Daniel's rate is 1/9, but I don't know Paula's rate, so I'll call that 1/x. Because if her rate is x hours per 40 bushels, that will give me the right result. Now t isn't a variable here. T is 4.95 hours, so let me put that in. And that way I have only one variable left in the problem. It's x. So my equation is 4.95 over 9 plus 4.95 over x equals 1. The common denominator is 9x, so let's multiply everything by 9x, and that gives me the 9x times the first term, which lets me cancel some 9's, and the 9x times the second term, which lets me cancel the x, and then 1 times 9x is just 9x. So I've cleared fractions, and I have 4.95 times x plus 9 times 4.95 equals 9x. When I subtract 4.95x from each side, 9 minus 4.95 is 4.05. So it's 4.05x equals 9 times 4.95, 44.55. Now I can solve by just dividing both sides by 4.05. And when I do that, I get x equals 11, which is kind of a relief with all those decimal points, huh? So what does that mean? It would take Paula 11 hours to do it alone.